So why is he here on an AP Environmental Science thing?
Because instead of stop hammer time, it's stop packet time. All right. So the first thing in your packet, the TFR is total fertility rate. Oh wait, does that come back after? I forget. Yes, it is. I thought I had, maybe I screwed up. I must have deleted something. All right, so CBR stands for crude birth rate. I'll make my screen bigger, that's really tiny. Is that easier to read?
Yeah.
Okay. And then CDR is crude death rate. So rather than just death rate or crude or death rate, birth rate, when the word crude is involved, it typically means number of deaths per 1,000. It's just kind of like the official term. So let me get that out of the way. This one right here, population density, is pretty easy. It's just population divided by area. I'll look, Leland. And then national growth rate. So you have your crude birth rate and crude death rate involved, but you also have immigration and emigration involved. So your national growth rates include both like births, deaths, and people moving in and out of the country. Global growth rate does not include immigration or emigration because we don't have aliens. That's just your crude birth rate and crude death rate, and they divide it by 10. Rate of natural increase. The rule of 70, this one I could almost guarantee would end up on your AP exam. So it's estimated, using the rule of 70, that population doubles when you take the number 70 and divide it by the growth rate. Like I said, we'll do examples of all these, but it's just kind of a given. I really don't know how to put this. It's just what they consider, what pattern they've seen at the current rate that we've been increasing. And then this is really similar to what we've been working on already, that n sub 0 equals n initial times e to the RT or whatever is pretty much this thing right in here. All right, so now we get to practice, and I'm going to try and do it in here with you guys. Given the following information, answers question 1 through 4. Petersonville is a utopic island of 5,000 square kilometers off the coast of Yomama. There are currently 250,000 inhabitants of the island. Last year there were 12,000 new children born and 10,000 people were reported as deceased. All right, now we have to figure out what is the population density. So what do? What numbers do I need?
Can you zoom out just a little bit?
What's up, Ashley? Yep. So I need my population divided by the area, which is 5,000. And I guess that should be proper. And the area is in kilometers, which gives us
I'm typing it up right now.
okay.
I got 50.
Good. Nice round 50. So 50 people per kilometer. And I'm just trying to get you guys in the habit of units. We haven't done a whole lot of math in a while, and you lose points on the exam even if you get the right answer but the wrong or don't put units. So trying to be in the habit.
People.
All right. What are the birth and death rates? So let's figure out the birth rate first. This one kind of has an extra step in it. What do we got to do with birth rates? What information do we need?
12,000 new children and 10,000 people recorded as deceased.
Oh, for the deceased. Okay. We're going to work on one at a time. I'm actually even going to put that right out here.
Is it 12,000 divided by 1,000?
Yes. Sorry, not by 1,000. We'll get there. I'll do that in the next step. So we take our total number of babies born, which is 12,000. We divide it by our total population. And then if I remember correctly, it should be this. Do you guys remember in math class, like where you have the two fractions equal to each other and you cross multiply and then divide?
Mm-hmm.
That's what I have written down on my paper right now. But because I don't want to write 1 over 1,000, I just wrote times 1,000.
0.048.
Yeah.
It's actually 6 over 125.
That is not what
Or is that multiplication there?
Hold on.
Okay.
I don't know where you even got that number, because even if you ignore the 1,000 part, it should just be off by decimal. Yeah, okay, so that's what I got too. Oops.
I got 12,000 divided by 250,000. And do I multiply 1,000?
Yes. So
48.
what it would look like if it was set up as a fraction, I guess would be over type. Hate not having a number pad. What I was talking about with the ratios. 1 over 1,000 because it's a rate per 1,000. So that's where Jesus had come in with the divide by 1,000 thing. But it's that ratio or that proportion. So it'd be 12,000 over 250,000 is equal to 1 over 1,000, or x over 1,000 is what we're really looking for. Is this a better way to write it? Does it make more sense?
I don't know. Because you put the equals instead of the asterisk.
Yeah. Hold on. Where's my mouse? There it is. All right, hold on. I'm gonna bring this over. Just because I know things look different on the calculator, on doing it online. You guys remember this from math class, right? Proportions.
Yeah.
So this would be 12,000 over 250,000, right?
Okay.
All right. This would be what we're trying to find out per 1,000 people.
The butterfly method. Okay.
Right. So it's A times D divided by B. That just gets, I felt that got really confusing trying to type it in Word, but if, I'll type it either way you guys need me to. but that's what we're working with here. So when we're finding birth and death rates, we have like, we're given in this problem the amount of people born, the total population, the per 1,000 we need to find C.
Okay.
All right, so that's why I had the times 1,000. So A times D divided by B. Or set it up as a proportion. And you should end up with 48. Jesus, don't worry about percent, just 48. All right, now we need to do death rate. Spell today. All right, how many died?
Dead, you got 10,000.
Here we go. Total population. What does that come out to be? I'm just writing it out both ways, whatever one makes sense to you. Well, the same thing. Good, Jesus got it. It is 40. Don't worry, this is not a percent or anything. You can just put 40. It's a death rate or birth rate.
Do we need to have the part that's below the other part?
No, I just wrote out the same equation done two different ways. So if you're cross multiply then divide, or like ratio, whatever, same thing.
But I still don't understand why you had the X.
That's your variable. That's what you're trying to find. This is 48 per 1,000 people.
Oh, okay.
This is 40 per 1,000 people.
How would you plug that into a calculator?
With an equal sign, you can.
Is there something else to place in between it?
That's why I did this down here.
Oh, okay.
All right, what is the population growth rate? So I'm just going to copy this down here. Our growth rate is our divided by 10. That's our formula. So, oh, I think I got it reversed. Crude birth rate. You guys know why I'm putting the parentheses, right? Okay. So we take, when we're looking for a population growth rate, we want to see how many more people are being born than how many people are dying. So that's our birth rate minus our death rate, which we got up here in number 2, 48 and 40, and divide that by 10. What does that give us as an answer? Yep. 0.8. And this would be a population growth rate is always a percentage. So you can, if you want, put the percentage, but I won't ask you to. All right. In how many years will the population of Petersonville double? What equation are we going to use for that? Which one has to do with doubling time? Yeah, the rule of 70. Very nice. So we just calculated our growth rate, and so we need that number divided by 70. So $70 divided by 0.8.
Rule of 70.
Yep. So rule of 70 is right up here. This is doubling time. So we always have the number 70 in top, and then we divide it by our growth rate. We figured out in number 3 that our growth rate is 0.8%. So I put it down in here. Jesus, you are correct. 87.5 years.
Wait, it says double it though, so how come you didn't? Oh, okay.
It's how many years would the population double? So our answer is going to be in years.
Okay, what? That confused me more.
How many years will the population of Petersonville double? Okay, so we take number 70, that's part of the formula,
Okay.
divide it by the growth rate,
Okay.
and that gives us years.
Got it.
Any questions on these first forks? We're about to do them all over again with some different numbers.
Nope.
So the number 70 is just part of the formula, right? It's not like, it doesn't matter what country you're talking about, what population, is it big, is it small, anything like that. Do they only speak English? It doesn't matter. There's always going to be that 70 there. It's just part of the equation. The part that you usually have to figure out is the growth rate, which we did up here. And then the answer is given in years. I honestly do not know where the 70 came from, how they came about the 70. I just know it's part of the formula. Oh, yeah, but it's a decimal, so it's going to be bigger. Yeah, I got what you're saying. All right, Newtown. Given the following information, answer questions 5 through 8. In the country of Transylvania, they contain 2.3 million people, vampires not included, and it covers 800,000 square kilometers. In the year after the last census, there were 109,000 new children born and 111,000 people died. All right. So, what is the current population density? I feel like this is always the easiest one.
2.3 million?
up, and I'm going to actually write it out. 2.3 million, let me zoom in, divided by
800,000.
Let's see. What does that give us? Good, 2.875 people per kilometer. And it actually should be squared. I guess I can put it in there. That's size, there it is. All right. What are the birth and death rates? So we got to do this one again. What's our amount of births? How many births?
1,000. I mean, 109,000.
And that goes over our total population of 2.3. Watching my zeros. This one is not a whole number. Would you rather me put the times 1,000? Oh, I lost my mouse. I'm sorry. There it is. The 1,000 KK? I don't have 10,000 anywhere. Oh, hold on. 47.3? Yeah. So the 1,000 comes from, I'm going to scroll up for a second, guys. Ooh, I scrolled up way too far. I know. So when we're talking about crude birth and death rates, here's that 3 a.m. I've been awake since. When we're talking about it, it's per 1,000. So that's where the 1,000 comes in. All right, what about death rate? Oh no. I am like a 90-year-old man trying to type without having to use all the numbers at the top of the keyboard, so I'm sorry. Jesus got in the chat 48.26. That is correct. So now that we have our crude birth rates and our crude death rates, we can now figure out our growth rate for the population. So our crude birth rate is 47. Which one? Oh, okay, yeah.
I got 0.0871.
Anyone that disagrees with Leland? 0.0871.
I got the same thing.
All right, KK says the same thing. Jesus has something a little different. Good.
Mine
Jack?
was negative.
Okay, there you go. It is negative. 47.39 minus 48.261 is going to give you a negative. What do you think it means if the growth rate is negative?
It's terrible. That means it must be below the death rate then.
So the
They're
population
dying
is
faster than
going
they're born.
down. It's not growing, it's shrinking. Very nice. All right, rule of 70. In how many years will the population of Transylvania double? You can check his room.
Wow, miss.
You can't have negative time. Yeah, anytime you have a shrinking growth rate, you're not going to be able to use the rule of 70 for doubling. I'm so nice about things. All right. What's that? Okay, deal. You can write it down. Good. Can I help you? No, it is not. All right. Given a 2010 world population growth rate of about 1.3% per year, I guess I should have zoomed out more. How long would it take the world's population to double? This is just rule of 70 again. What was our growth rate?
No, negative 0.087.
For number 9.
Number 9? Oh, oops. Number 9. The growth rate. Where's that at? Wait a minute.
Who's got it? It is 1.3% per year.
Where'd that come from?
Right here.
Oh. I got 53.84615,385.
Yep. I'm just gonna.
Or 53.84.
Yep. That works for me. That's in years. Because you guys are differing ages, you get to put different things here. This will be the old.
$89.84.
That's how old I'll be. You guys got to type in how old you'll be. I'll be like 90 years old.
So where do we plug in our age at? The 1 point, no, not 1.3. This.
I lost my mouse. There it is. So if you were, what is it?
16.
You're 16. So that would be.
Wow, I'm going to go more than 10.
Roughly. Decimal doesn't really count. I don't care.
But how'd you do that? Where'd you plug that into?
Take your age and add that.
Oh, okay.
All right. If a country doubles its population in 56 years, what has its population? Oh, that's bad English. What is its population growth rate during that time? That was bad. Yep. So in fraction form, it would be 70 divided by x equals 56 years. We have to figure out that x. So if you guys remember algebra class or integrated 1 or 2, or I honestly don't know because I hate the integrated program, you would multiply both sides by x, divide both sides by 56 to get x on its own, or swap them. There's definitely so what does that make? Yep. That means your growth rate was 1.25%.
So okay, I see now.
Jesus is calling me wrong, and now he changed his mind. That reminds me, I used to have a student when I taught algebra.
You're correct.
Would raise his hand, ask for help, I'd explain it to him, and then he'd tell me, "You're wrong." Every time. Every time. Yes, it does. Except for he was serious. He would be joking with me. All right. So, calculating growth rates and doubling time. We've got this whole table to do, but once you do one, it's super simple because it's the same process the whole time. All right. I'm screwing up all my papers here. So, in order to get growth rate, all we have to do is birth minus death. 13 minus 8. Yep, is 5. And then divide that by 10. That's part of our formula. If you don't remember the formula, look up. Or I'll actually stay consistent and write it the exact same that I had.
0.5.
0.5. And then all we do is plug it into the rule of 70 here. So 70 divided by 0.5 is what? All right, good. 100. Okay, that's all. That's all you're doing for the whole tables. You're just practicing growth rate and doubling time. So I'll give you guys a few minutes to work on this, and I'll start calling on people at 12:25. Maybe. Yeah. Oh, I did scroll down. Sorry.
I got 50 years for the second one.
All right, keep going. I'll have to zoom out. I can't get both of them in. All right. There you go, Naija. Yeah. Oh, yeah. If you do it negative, then double times negative. Yeah, you don't have to do any calculations if the growth rate is negative. Which you should run across 2 of them like that. And literally, it could run. Somebody in my first line last year, mine was like on like that. Like this phone calculator, like we just do basic math in it, and it's all over. Oh, it was so weird.
Wow. Here's what I got. I'll show you.
All right, Dante, since you're done, what'd you get for Mexico? All right, 1.4 and 50. That is correct. I'm just going to put in the answers. If you need me to walk how how to get those, please let me know. You're going to be an Excel junkie like me, Dante. All right. Leland, Japan.
You said Japan?
Yep.
Japan. See, I got 70.1.
Wait, what?
70.1.
Oh, I need the growth rate.
Oh. Oops. The growth rate was 8 minus 9 equals -1 divided by 10 equals 0.1. Negative 0.1.
And why do you
disagree with
Jesus likes to disagree. Why do you disagree with 70.1 as a doubling time? God, it's shrinking! All right. KK, United Kingdom. I just started typing stuff. All right, there we go.
Okay, so for United Kingdom, I got 0.4 and 175.
Good. Ashley, you got China?
175.
Daryl, sorry, Keontae, did you get India? .6. All right, 2 left. Who do I?
Where's it? The 44?
I haven't heard from you, Nigeria. Oh, it might be on the next page. The Quiet Keenan.
Oh. Is this India?
Oops. Yeah. Yeah, mine just bumped to the next page because I spaced some of this out.
Right.
All right, somebody save Keenan. .5. Oh gosh, I'm giving that. Hold on. 2.5. See, I type like a 90-year-old man. In 28 years. Perfect, Jesus. Nigeria, South Africa. Oh, that's right. Her mic doesn't work. I have to wait for her to type. As I say, just hold it in your pocket, warm it up. Okay. Let's see. South Africa, I got 0.7. There we go. Javea came to your rescue. Javea, you can take the next one. Do Canada. Since I stole your thunder. Hey, Leland, what about Italy?
-1. Negative 0.1.
Doubling time.
None.
0 centimals, or none. All right. Yes, I can scroll up. Actually, I'll do this. All right, there's your answers. If you missed one and I scrolled too fast, I'm going to scroll in a second. This?
Yeah.
It's this one's right here.
I know, but when I went to the packet one word, like that whole word.
Oh, it doesn't? Oh, that's weird. I'm sorry. It might have gotten hidden behind the table with my head. But all right. In April of 2010, the U.S. population was 308,745,538 and is growing at about 0.97%. Assuming a consistent or a constant growth rate, what will the population be in 2020? So that we have to, well, we don't have to. I'm just going to scroll back up and show you where that was. Finding future populations from growth rate. So we're going to take that initial population, we're going to multiply it by our growth rate, and our exponent is going to be the years. So it'll be really easy once we get one of them. So let me do the first one for you guys. And I will also have to explain something. So give me a second. God, that is not what I meant to do.
You always put 2 zeros before the actual percentage.
Yep, that's what I'm going to go over in 1 second. I just want to get this typed out since I type like an old man. I would be done in a freaking 10 key. Okay. So this one looks a little funnier because we've just, like with the growth rates and stuff, we've left the number as is and used it. When we're talking about future populations, this is where it changes a little bit. So if you've done growth and decay in your math classes, like exponential and equations, it's always 1 and then plus or minus the percentage rate. 0.97 taken out of percentage and put back into a decimal is 0.0097, right? And because it's increasing, it's got to be 100% plus that 0.9%. Does that make sense on why it's not just 0.97 right here?
Yeah.
So that should be your answer there. And the 10 comes from 10 years having gone by. So this is the 2010 census, and it's asking what will the population be in 2020. So I'm going to just copy and paste so I don't have to type this stupid thing out again. All right, in 2050 though, my years is going to change. Oh, I didn't mean to copy that. What are my years going to change to? From 2010 to 2050. 40. Oh, gosh dang it. So 1.0097 to the 40th power, which is many people. That is the answer to everything. All right, what about 2100? Good. That will be to the 90th power. If I type something wrong and you notice, you're more than welcome to correct me. KK, I did that exponent. Up here, you can do a subscript. So if I was doing like glucose C6H12O6, I could use that to put the low numbers. For exponents, I do the superscript, and it just puts it up really tiny and high. What? I do. I used it this morning. All right. So that's all it is. It's an easy equation. I think this was the only tricky part is if it's growing, it's got to be 1 point something. If it's negative, let's say it was one of those fancy negative growth rate countries, it would be 0.00 whatever that is, okay? So do keep that in mind. This is the current birth to death rate. Jesus, if you're talking about our country, I don't know at the top of my head. All right, what would happen to the population growth rate of a country that maintains a high crude birth rate of 32 but was able to reduce their crude death rate from 28 to 12? So we've got to do two tiny equations here. We're familiar with our birth and death rates. So the original one would have been 32 minus 28. 10. What does that give me? I'm going to zoom
in. Okay, I got 0.4.
Okay. And then our other one, they got their people to stop dying, I guess. Down to a crude death rate of 12. Yeah, I got the same answer, Jackie, so I'm double checking. What is it? 32 minus 12. Yeah, I got 2 for that one, Jesus. Which now makes me want to check this one, because I think I know. Oops. No, stop it. Delete.
Yes, 2.
Yeah. Oh my gosh. 30.
When I forget the parentheses, it gave me 30.
Yep. Yeah, I was thinking that might be maybe what happened. Okay, there we go. Yeah. All right. So we have our two different rates. What would happen to the doubling time? So it's just 70 divided by 0.4. That number, 70. Say that again, 175? Doing this kind of at the top of my head on this one. All right, so instead of taking 175 years to double their population, by reducing that death rate, it changed to 35 years to double that population. else still need that? This table is just like the previous table. Once you get like one equation down, like the rest just kind of flow. You're just substituting in the numbers that it gives you, okay? So while it may feel a little overwhelming, it actually goes by pretty quick. All right, so we are currently adding 84 million people to the world's population each year. That is about 229,000 each day. Below is a listing of some of the world's worst disasters along with the approximate death toll. At today's growth rate, determine how many minutes, hours, days, weeks, or months it would take to replace those that are lost. So we lost just over 1,800 in Hurricane Katrina. This, let's see. How do I want to explain this? This goes back to doing the ratios or the proportions. Okay, so I'm going to put the equal sign in here again.
Oh, so what do we put for x?
That's what you got to figure out.
Okay.
So this is that, I think, would you call it the butterfly method or something like that?
But
Okay, so it ends up being like 1,836 times 1, because it's 1 day, divided by 229,000. This is when I figure out how good you guys are at working with time. Because time goes in 60 minutes and 24 hours, not units of 100 like your calculator does. I'm definitely noticing I made an error. This is the second error I made in my stupid answer.
Is it in this equation here?
So you're looking for the answer.
124.
But you it to like seconds, minutes. Oh, that's what I did, I think. Seconds, minutes, or hours, or whatever it may be. Now think of this logically. So if you say 124 days, okay, there is 229,000 people being born each day. So we should be looking at an answer of less than 1 day.
Maybe 24 hours. Wait, no, that is a day.
That is a day. I did my math wrong on this one on my answer key, so let me double fix that. Hold on. 36. So much for doing better. There we go.
60. Maybe, I don't know, an hour.
Oh my gosh, I can't deal with this. So whenever you guys text, it comes across the top of my phone, and then it blocks out everything I'm trying to do with my calculator. There. But Oh my gosh. Divided by.
Variable x, wouldn't that be 60? You said less than a day, less than that would be an hour.
Yes, it's less than an hour, I will tell you that.
Less than an hour?
Yes. Except for I keep putting too many numbers in here. Oh my god. Oh my gosh. Oof. It's in back. Like you said, we only got, what, 4 minutes left?
How would we figure this out? Do we just divide?
Hold on.
Right?
18, 26.
Well, I divided 1836 by 229,000. I'm not exactly sure if I did that right. 8.017.
So yeah, it comes out 0.008 whatever times by, hold on.
Wait, what?
All right, I'm gonna figure out what I did wrong in my answer key, and I'm gonna get back to you guys tomorrow. So skip that table for now. I'll figure out what I did wrong in my answers, because I'm scared if I did the first one wrong, I might have like copied and pasted all the way down, and I don't want to do that to you guys. Okay?
Okay.
Yeah, not tomorrow, but Wednesday. Just know anytime I say tomorrow, the next time I see you. All right, so skip that table. I'll give you whatever I did wrong last time, because I don't want to give you wrong numbers. We got 2 minutes left.
Do you still want to do the deal off for this section?
There is, but it'll be included in the stuff tomorrow. We have like a couple more slides left. A little bit of math here, but way easier. Like the one we did 10 years, 40 years, 90 years from now. Graph it, answer questions about it, and then we'll get into some other stuff Wednesday. I was going to say tomorrow, but y'all are picky. So Wednesday, when I see you again. Other than that table that I screwed up on, is there any other questions?
Nope.
All right. Then if there is no questions, I will let you guys go.